Hello everyone, I'm Nagarjuna Malladi. Today I'm going to talk about the multifaceted landscaping of site reliability engineering (SRE), a deep dive into expertise specific concepts. We'll discuss about this table of contents. You can review them once. Let's go into introduction to SRE. So, site reliability engineering (SRE) is a discipline that merges software engineering with IT operations. It emphasizes the primary goal of ensuring system reliability, performance, and scalability, especially as system grows in complexity. SRE originated at Google and integrates engineering practices with operational responsibilities. SRE is a relatively new field that has gained prominence, especially in the tech industry. It recognizes the need to address the challenges of managing complex systems in modern dynamic environments. SRE, I can tell key goals of the SRE: enhancing system availability and reliability, ensuring that services function reliably and are available to users, and automatic operational tasks just to reduce the manual errors and making things more reliable. Efficiently managing system failures by reducing recovery time, thereby minimizing service disruptions. So these goals showcase the proactive nature of SRE. It's not just about reacting to the failures, but also about preventing them and ensuring systems are robust and resilient. So cloud native infrastructure platforms. It's introduced the concept of cloud native infrastructure, highlighting industry leading cloud services providers such as AWS, Azure, GCP, and OCI. These platforms offer scalable and flexible computing resources. Cloud computing has revolutionized how organizations manage infrastructure, providing on demand resources and scaling capabilities. Core technologies in SRE. Infrastructure as a code. Tools like Terraform allow for consistent infrastructure provisioning and management. Serverless computing platforms, AWS, Lambda, Azure Functions, GCP, Cloud Functions enable running code without managing servers. Containers orchestration, systems like Kubernetes, ECS, AKS manage and scale containerized applications efficiently. Cloud native security solutions ensure secure access and data protection in the cloud environment. These technologies are pivotal in modern software architecture, enabling dynamic and scalable infrastructure with enhanced security measures. Let's discuss about networking in SRE. Designing resilient network topologies with redundant and low latency. Performance monitoring, like tracking metrics like latency, throughput, and jitter using machine learning for anomaly detection. Network security, employing firewalls, IDS, IPS, VPNs, and zero trust architectures to safeguard the network. DNS and CDNS, optimizing domain name resolution and content delivery to reduce latency. Networking is the backbone of any distributed system. Efficient network design and performance monitoring are crucial for ensuring reliable and responsive applications. Let's go to database. Database management and reliability. High availability through replication ensures continuous access. Disaster recovery mechanism including backups, geographic distribution, safeguard against data loss. Think about some natural disaster happening in any area and having a disaster recovery for those data centers. How important is for the clients, customers, or everyone like company having this disaster recovery of data. Performance optimization techniques that improve query efficiency and implement caching mechanisms. Security measures protect data, employing encryption, access control, and data masking. Comparison of NoSQL and relational databases highlights their respective advantages. Databases are critical assets for any application. Ensuring their reliability, performance, and security is essential to maintain system integrity. I can spend a lot of time explaining only on this slide. It has so much data there. In the event of time, I'm going for other slide. Observability and monitoring. Metric collections capture resource utilization, latency, and error rates. Centralized logging tools like Elk Stack, Splunk aggregate logs for in-depth analysis. And now clouds are doing their own open search, and that's for the same reason. Distributed tracing assists in tracking request flow using tools such as Jagger and Zipkin. Alerting systems leverage dynamic thresholds and anomaly detection to trigger notifications. And then by using of machine learning and AI, this can find the pattern also at what time the system is going high CPU, at what time the system having more load. That kind of good information we can get. And metrics framework establishes SLIs, SLOs, and SLAs for and managing reliability. Observability tools enable SRE teams to detect and resolve issues promptly, ensuring efficient system management. Let's go to automation and DevOps. It's one of my favorite topic. CI/CD pipelines for automated testing and deployment using Jenkins, GitLab CI, and GitHub Actions. Configuration management tools like Ansible, Puppet, Chef ensure consistent environments. Scripting languages like Python, Bash, PowerShell automate repetitive tasks and checks. Incident response automation focus on self-healing systems to minimize mean time to recover. Chavos engineering introduce controlled failures to test system robustness. This level management sets targets SLOs and agreements SLAs for reliability measurement. Capacity planning utilizes ML and trend analysis to predict resource requirements. Automation streamlines processes, allowing SRE teams to manage complex systems efficiently. Chavos engineering might seem counterintuitive, but it's a proactive way to test system limits and enhance resilience. Let's see some advanced topics. Chavos engineering. It's a practice of introducing controlled failures is further emphasized with tools like Chavos Monkey. Error budgets allows team to allocate risk and balance stability with innovation. Capacity planning techniques employ machine learning to forecast resource needs accurately. These advanced concepts showcase the strategic thinking involved in SRE. It's about staying ahead of potential issues and optimizing system capabilities. Industry-specific SRE considerations. Financial services emphasize security, regulatory, compliance, and handling with high-frequency transactions. E-commerce focus on massive scalability demands, especially during peak times and fraud prevention. Healthcare prioritize data privacy, ensure and manage life-critical applications. SRE adaptability allows teams to tailor strategies to introduce strategies to industry-specific needs, ensuring systems are reliable and think about financial services, financial companies, JP Morgan's, and a lot of banks, Capital One, Citibank, see how important for them the security and having high frequent transactions, how important to make their system always up and running. And think about e-commerce. In the Black Friday, the load on the e-commerce systems, Amazon, Walmart, like you think about anything like Apple's, Samsung's, like mobile phones. So there's so much load on these systems. And then if they're down for some time, the companies have huge loss. And then a lot of folks try to do fraud also at this time. And then we need to prevent those transactions as SREs. And then think about data healthcare and how critical it is with a lot of viruses and all, how critical the trials are. The companies that do Lilly, Pfizer, and a lot of healthcare Mercs, they are like very important. And then keeping patients' data secured. Yeah. Other than regular information, doctors also cannot see all the patient information because of this HIPAA rules. So that's important. That's how it's very important in the healthcare industry. Let's conclude. So, in conclusion, this encapsulates the essence of SRE, emphasizing its value in achieving reliable, scalable, and efficient systems. By harnessing automation, observability, and robust incident response practices, organizations can manage complex infrastructure. The adoption of cloud native technologies and CI/CD pipelines enhances SRE effectiveness. SRE has become an dispensable aspect of managing modern software systems. It integrates engineering principles with operational best practices, ensuring organizations can scale their services reliably. If you have any questions, if you need any suggestions, you can reach out to me. You can search my name on the LinkedIn, Nagarjuna Malladi, and you can find me. And you can send me a note. I can able to answer if you have any questions or if you need any recommendations in terms of site reliability engineering. Thank you very much.